Hi, everyone, and welcome to the Spring Break 2018 edition of our review packet. So, this will be part one. This will be looking at the first six problems. So, let's get to the first one. The grass clippings here. This one right here, again, a calculator is required. A couple things to keep in mind when you're working on these is especially when you're dealing with the uh, the average rate of change. If you take a look, the average rate of change right there. That right there is going to tell you when you see that they're saying over this interval from 0 to 30. So what they want you to do, you're looking at finding a slope. So you're looking at change in y over change in x. Keep that in mind as you're working on that. Okay. And then find the value of a prime of 15. Again, this is your calculator. So in this case, I would be jumping right to the numerical derivative. Remember using correct units. Remember when you're doing the units for a derivative are the y units divided by the x units. The units for the antiderivative or for a definite integral are going to be the y units times the x units. But in this case, the units are going to end up being in this case, the units for a, which is pounds, and t is days, so it's going to be pounds per day. Now let's take a look at part C. In this case, they want to find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over that interval. Okay, so keep in mind what you're looking at there. The average amount of grass clippings in the bin over the time interval, that's your answer from part A. Okay, and then so you want to work with that. And really what this is getting to is the whole mean value theorem. And then, excuse me, for part D, what we're looking at is the linear approximation of A. So what they're saying here is that after 30, you're going to want to use the equation of the tangent line at t equals 30. Okay, so we're going to want to do that, and then you're going to predict when the time at which there will be a half a pound of grass clippings remaining in the bin, and show all the work leading to that answer. Okay, let's take a look at the second problem. In the second problem here, you have that region R, which you see right here, and it's enclosed by this function here and the line y equals 4. Okay, so in this case, really look at this thing. I would sit there and say, you're looking at this thing. I would want to do vertical slicing on this. So you want to go through and find the volume generated when rotated around the horizontal line, y equals -2. So working with this. Now keep in mind, while we did talk about you have disc and washers, and then we also talked about shells in terms of finding a volume by rotation. The AP exam is generally going to focus on the discs and washers. That would be the one that you're going to probably more likely use. But if you see a situation where you would like to do shells and it would be okay, mathematically there's no issue with it, then that's not going to be a problem. You can use shells as well. And really, like in this case right here, if they wanted you to go and find the volume here, but you want to around a vertical line, obviously I would prefer to use shells there. But more than likely, if you're going to have a choice between shells or using discs or washers, it's going to be in a region where the type of slicing is not going to make a difference, where you could use either horizontal or vertical slicing. For part B, the cross section is perpendicular to the x-axis as an isosceles right triangle with a leg in R. So keep that in mind. Okay, it's an isosceles right triangle, so it's a 45, 45, 90 triangle. And the leg is in R, so that kind of helps you out in terms of base and height with that. And then we saw this before in a previous one that we did in the 2012 packet that we did in class. We have a vertical line, x equals k, divides R into two regions with equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. All right, so you have, again on that one, you do have multiple multiple ways of solving that. It's really going to be up to you how you go about working through that one. But in this case, you just have to write any integral expression that will go through and that could solve it. You don't actually have to figure out what k is. So keep that in mind as well. Now we're getting into the non-calculator questions. So the first two questions were both where you would have access to the calculator, and I would, whenever possible, whenever you needed to do any of the integrals there, I would go through and use the calculator. A couple things you have to keep in mind with that too is because sometimes you'll look at a problem, you'll think that you can integrate it. But it may not be one that you can integrate. So focus on using your calculator whenever necessary on there. You do get your calculator for 30 minutes, and so you should be able to finish those, the calculator portion anyway, the parts that do require a calculator. You should be able to get those done in that time. Remember after the 30 minutes that you will get your calculator goes away, but you still have access. You can still do work on problems 1 and 2. Now we get to problem 3. In this case, what we're dealing with here, we have the this function. This is the graph of f. So always go through and double check and make sure you identify those. As defined on the interval from -5 to 4, the graph of f consists of 3 line segments, so you know those are linear, so that can come into play in terms of slopes and things like that. And you're going to want to go through. G is defined in this way right there. Okay, now that right there, without even looking at the problem, I'm thinking that somewhere in there I'm going to have to go through and deal with G prime. And G prime in that case is going to be dealing with that fundamental theorem of calculus, where you take the derivative of that integral. And remember, you think back about what, in essence, ends up happening with that. So the first part here, we have to find g of 3. G of 3 is, g of x, remember, is defined as the integral from -3 to x. So it's going to go from -3. So g of 3 is going to go from -3 to 3. And you're going to have to approximate, you're going to have to go and give me that definite integral. Now, the thing you're going to have to deal with for 3, you're going to need that slope. The slope of this particular line here, you're going to need that to identify what that slope is so that you can get the proper y coordinate for f of 3. So, okay, so you got to have that. So keep that in mind as you're working on that. Part B on this one. On the open intervals contained in -5 to 4 is the graph of G both increasing and concave down. Give reason for your answer. So you're supposed to identify what it means to be for the graph of G. Think about what the derivative. So this is where G prime is going to come in, because if you're going to be increasing and decreasing, you got to know what the derivative is, and concave down, you got to know what the second derivative is. So it's really asking you to go through and use the characteristics of the first and second derivative to go through and determine when this thing is going to be increasing and concave down. Give reason for your answers. Okay. In this, it is possible that you may not have an answer too. Okay, that is a possibility as well. Okay. Part C, the function h is defined in this way right here. Find h prime of 3. This one right here, and I've seen it a couple times recently from different people, is where you got to be careful. You got to remember what's happening on this thing. H is a quotient, so remember the quotient rule when you're dealing with that. Okay, and function p is defined in this way here. P of x is f of x squared minus x. Find the slope of the tangent line to the graph of p at the point x equals -1. Take the derivative. Take the derivative. Remember, x squared minus x, that's your inside function. So remember your chain rule on that one. Okay? Hopefully, these are going pretty well. And you've been able to accomplish some of this so far. Now we get to problem 4. Train A runs back and forth on an east-west section of the railroad track there. Train A's velocity, measured in meters per minute, is given by the differentiable function, where t is measured in minutes. Selected values of our velocity function for A are given in the table up here. So remember, up here, this right here is the derivative of your position on that one. Okay? So first thing they want you to do, find the average acceleration of train A on the interval from 2 to 8. Okay. Remember, this is velocity. What they're asking for is the average acceleration. When this function that they're asking for here is the derivative of this, that's just telling you find the average rate of change. So you're going to go find the slope from 2 to 8. Is really what they're asking for on that one. So just use the point at 2, the point at 8, find that slope. You should get your answer there. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t from 5 to 8? Give reason for your answer. Okay. On this one right here, from 5 to 8, that it's going to be negative 100. The velocity will be. Okay, so you're looking at here, it was 40 and negative 120. Think about this is a differentiable function. The derivative obviously exists between 5 and 8. So, when you have that right there, it is continuous. So keep that in mind and think about the different theorems we have. Most specifically, you have the intermediate value theorem you want to be aware of on that one. For part C, at time t equals 2, train A's position is 300 meters east of the origin station. Okay. So when we're looking at that, we're going to be 300 meters east, and the train is moving to the east. Write an expression involving an integral that gives the position of the train A in meters from the origin station at time t equals 12. Use a trapezoid sum to go through and with the three subintervals indicated to approximate its position. Well, remember on this. So 300 east, at t equals 2, we're 300 meters east and we're moving east. So that would tell me that the positive velocity here is going to be east, negative velocity is going to be west. So you're starting out at t equals 2, you're going to be 300 meters east of the origin station, and so they're going to ask you to go from there, use that sum to go and find that total, or find the approximate position at time t equals 12. So you're using the 3, so you have 2 to 5, 5 to 8, and 8 to 12. A second train, train B, travels north from the origin station. At time t, the velocity of train B is given by this function here, and at time t equals 2, the train is 400 meters north of the station. Find the rate at which, in meters per minute, at which the distance between train A and train B is changing at t equals 2. All right, so big thing you got to do there, draw this thing out. So you know on this one that we're going, you have train A and train B. A is here at t equals 2. That distance is 300, and it's moving in that direction at 100 meters per minute. And train B is up here, and that distance right there is 400, and they give you a velocity function. So you can plug 2 into that function right there, and you're able to determine what the velocity is at time t equals 2. And if you take a look there, you might recognize a right triangle here. and that's 300, 400, so that might give you an idea what that length is there. But use that information to go through and separate. It's a related rate problem, okay? And right triangle is screaming Pythagorean theorem, so you should be looking at that on this one. Now let's move to problem number 5. Problem number 5, we have this twice differentiable function. Functions f and g are defined for all real numbers. Okay, so that's a key part right there. They're defined everywhere. Values of f, f prime, g, and g prime for various values of x are given in the table above. First thing they want you to do, find the x coordinates of each relative minimum of f on the interval from -2 to 3. Justify your answer. Remember what happens in terms of a relative minimum from -2 to 3. It is, you have that whole portion there. Remember what has to occur with the derivative. Okay, you got to think, okay, relative minimum, what has to happen with the derivative in order to go through and to say that I have a relative min or a relative max. Look at that in terms of make your determination there. And you're just asking to find the x coordinate, although you could also get the y coordinate on this too if it was possible. Next one, explain why there's a value c for the interval from -1 to 1 for which c double prime, or f double prime of c, sorry, is equal to 0. Okay, why would that be the case? Well, if you take a look from -1 to 1, we know that if f double prime of c equals 0, this would be by the mean value theorem, that there must be a way that you can go from that f prime of 1 minus f prime of 1 all over 1 minus the -1. That would have to be equal to f double prime of c. But if you take a look there, look at the mean value theorem, that would end up being your case there. Mean value theorem on something like that, when they're asking you to go and explain why something must exist, you really should be thinking either mean value theorem or intermediate value theorem. Remember the mean value theorem. The mean value theorem states that the derivative of a function f prime of some number c is going to be equal to f of b minus f of a all over b minus a. But now I did this as the derivative of a function f. But keep in mind, that could be f double prime and f primes up there as well. Okay, so just keep that aspect. But this right there, that's the mean value theorem, or MVT. Okay, the intermediate value theorem is another one. We saw that earlier, but this one right here is the mean value theorem. And they do want you to state that like on this one right there, you could just say by the mean value theorem, this has to all you'd have to say is this has to happen since, and then show the work that this slope part that you'd have up here, that this slope part would be equal to 0. Okay. Next one, you have the function h is defined in this way. Find h prime of 3. Well, what you're going to do, take the derivative, remember the chain rule. And then right here on part D, what I would do if I were you, I would do a complete change of variable on that one. Let u equal g of x, and then go from there. Do the substitution, take the antiderivative. You could even go to the point where you even change the limits, where you can change that limits, because you know what g of -2 is, and you know what g of 3 is. Those are given to you in the problem. Okay, so that's kind of where I would go with this one. Do that change of variable. Let u here. I would let u on this one equal g of x and go from there. Now let's jump to problem number 6. In problem 6, we're going to consider that differential equation that we see there. It's dy dx equals 3 minus y times the cosine of x. Let y equal f of x. Be a particular solution, blah, okay, with the initial condition f of 0 equals 1. All right. The function f is defined for all real numbers. First part here, a portion of the slope field for the differential equation is given below. Sketch a solution curve through the point 0, 1. So you got to go to the point 0, 1. Now you'll notice you'll have to take a look on this when you do that, because you'll notice here that's 3. So there's 2, and there's 1. So when we do that one, I'm going to have a point right there, and I want to sketch a solution curve that goes through that. Now you want to be fairly, be as accurate as you can. Keep in mind that this is an approximation, so you can be off a little bit, but you should be following along fairly well with that one. Okay. Next, we want to write an equation for the tangent line to the solution curve at part A at the point 0, 1. Use your equation to approximate f of point 2. All right. So you have a point. In this case, you have the point 0, 1. You have this up here. Okay. You need to go through and evaluate, find the slope, and get that equation, that equation for the tangent line. And again, there's, unless you really want to, although they do give you, it is in the y-intercept, so your slope-intercept form would work fine with giving that out. The other thing you have then after that, you do have to evaluate f of 0.2. Remember, just put 0.2 in for x, okay? There's that. But now in terms of this, I'm not sure. I'd have to take a look. I can't remember in terms of how this works. If this would be like 1 point, this might be 2. The part A might be a point. Part B might be 2 points. So we're looking at 6 points, I'm thinking, when I look at part C. And this one is your particular solution to that differential equation. So on that particular problem, really what you know you're going to have to do on that, you're going to have to remember the whole process with this. You get 0 out of 6 if you don't separate those variables. So the very first thing you need to do is get those variables separated and then go through and do the antiderivatives. Now, when you separate the variables there, you're going to get dy over 3 minus y equals cosine x dx. Well, the integral of dy over 3 minus y, keep in mind the derivative of this inside function is negative, so be aware of that. And then the integral of cosine, just be aware of that one as well. And the other part is you do have to solve it for y. You're going to get 1 point for just getting that thing solved for y. Okay? So also when you're dealing with this, don't forget the plus c. Probably on this one, it's going to be 1 point for the separation of variables, which I just wrote out. 1 point for each antiderivative for 3. And if you don't give the plus c, that's all you're going to get. Okay, so remember to put the plus c after you take your antiderivatives. Okay, so with that does conclude my quick little hints video dealing with this first set. In terms of this, we don't have class until Wednesday. So if you wanted to see me on Monday, you can do that during SRT. If you want to go over, if you have any questions dealing with this or the other one, I will try to get another video made for the second part, either tomorrow or Monday at the latest. So anyway, hope you've been enjoying your spring break and you're having fun, and I look forward to seeing you on Wednesday.